Buenos días a todos y a todas. Buenas tardes a los que saludamos en Israel hoy, que son ya las 3 por allá. Bueno, muchas gracias a todos por su paciencia y a todos los que se están uniendo. Les vamos a dar un minutito más a todos los que están con nosotros. Bueno, aprovecho para los que ya están de recordarles que tenemos traducción simultánea. Muchas de las presentaciones que van a escuchar hoy son en inglés, así que abajo en la barrita de herramientas van a encontrar un puntito con la traducción y ahí van a poder conectarse al canal que desean, inglés o español, y ahí va a estar Claudia Ormazábal, nuestra intérprete del día de hoy. Así que, bueno, muchas gracias a todos. Veo que ya están todos conectándose. Vamos a partir. Me gustaría darles la más cordial bienvenida a este webinar sobre donde vamos a tratar específicamente el tema de innovación y sustentabilidad para la industria del salmón. Mi nombre es Valentina Gutiérrez, soy gerente de innovación de la Agricultura Comercial de Israel en Chile. Y es un honor hoy día contar con la presencia de autoridades, inversionistas, empresarios, representantes de la academia y a todos los profesionales presentes. Muy bienvenidos. En la agregaduría comercial trabajamos para estrechar lazos, compartir la innovación y soluciones tecnológicas, donde la esencia de nuestro día a día es apoyar a las iniciativas de cooperación bilateral entre Latinoamérica e Israel, potenciando el desarrollo y el crecimiento de todos los sectores, como en materia de recursos hídricos, agrotecnología, energía sustentable, minería y muchos otros. Y estamos muy felices de contar hoy con nuestros invitados especiales, Adolfo Alvial, director ejecutivo del Club de Innovación ACUICOLA, y Roni Sussmann, directora ejecutiva de AquaculTech Israel. Espero que lo disfruten y los invitamos a enviar sus preguntas por el chat, que vamos a tratar de contestar al final de las presentaciones. Algunas presentaciones van a ser en inglés, así que abajo les recuerdo nuevamente que pueden seleccionar en el botón del globo el caso de traducción simultánea con nuestra traductora Claudia Ormazábal. La sesión va a ser grabada, el link luego va a estar a disposición de todos y los que solicitaron reuniones uno a uno en el registro van a ser contactados luego para tener sus reuniones. Ahora quiero invitar a Yarit Goldberg, el agregado comercial de Chile y Argentina, para que nos dé algunas palabras. Yarit.
Sí, thank you, Vale. Good morning and afternoon to everyone, both in Chile and, of course, from Israel. It is my pleasure to welcome you all to this webinar about the innovation and sustainability for the salmon industry. My name is Yair Goldberg, and I'm the commercial attaché of Israel to Chile and Argentina. And on behalf of course, of our mission, I really want to thank you all for joining us today. At the Israeli Economic Mission, our mission is basically to make a win-win situation between Israeli companies and local market needs. We want to find those needs in the local market, to understand what they need, what are the opportunities, and to find the right Israeli company with the right technology and to do the right matching. Now, the idea is not just to close a deal, the idea is to make a partnership, something that can sustain for a very long time as much as possible. Now, the salmon industry represents a strategic sector in Chile and also one of a global impact. I mean, Chile is the second largest product on farmed salmon worldwide, and the industry plays a very key and role element in Chile. And you can see everything inside, the amount of technologies that this sector needs, either by the matter of employment, experts, regional development, and others. And of course, there are a lot of issues that we need to attend. For example, issues like sustainability, biosecurity, water management, environmental impact, and others. Now, these are the things that Israel is really good at, okay? We are really familiar and have the right technology about water and agriculture and data-driven agriculture and sensors and all the other things. And this is why this collaboration between Chile and Israel makes sense. There are a lot of key elements that just come together. Now, today webinars is designed to be as a starting point. This is supposed to be a space to share knowledge and maybe to identify opportunities for pilots, partnerships, and joint activities and developments. We really hope that this session will make new conversation between Israeli and Chile's companies, and maybe to start to have a new beginning of all kinds of projects in the future. And I really want to thank you all for joining us. And I wish you all to have a very good and productive webinar. Thank you very much.
Muchas gracias, Yarir. Ahora los dejo con Adolfo Vial, el director ejecutivo del Club de Innovación ACUICOLA, que nos va a hablar un poco de la cooperación internacional y nos va a hacer un overview del mercado y de la industria en Chile. Adolfo.
Muy buenos días a todas y a todos. Un agrado poder compartir con ustedes. En primer lugar, un agradecimiento a la embajada por esta invitación. Y brevemente voy a hacer una descripción de la industria, su situación actual, sus perspectivas, especialmente con énfasis en la innovación, que es donde a nuestro club le importa mucho establecer vínculos con proveedores de Israel. Creemos que hay una oportunidad muy grande de cooperación para seguir avanzando en el desarrollo de esta industria en Chile y en otros lugares del mundo. Así es que estamos muy esperanzados de que sea un muy buen encuentro y el inicio de una relación muy cordial y cercana y de mucha cooperación. Bueno, tal como se ha señalado, Chile es hoy una potencia mundial en acuicultura, particularmente de salmón. Sin embargo, además de salmón, donde somos el segundo mayor productor de salmón atlántico en el mundo y el primero en salmón del Pacífico y trucha arcoíris, y también el primer exportador de mejillones a nivel global. Entonces, es más que salmón y tenemos alrededor de 50 años de desarrollo bastante sostenido de la acuicultura comercial en el país. Eh, y es importante destacar que desde el principio la acuicultura chilena, especialmente la salmonicultura, tuvo un fuerte enfoque en la exportación y en la innovación. Es un sello que es importante tener presente porque del clúster industrial que se formó, el ecosistema de innovación estuvo muy presente desde el comienzo. En realidad, la innovación, la industria del salmón fue una innovación en sí misma, a gran escala en el sur de Chile. Aprovechó las oportunidades que había de mercado en el mundo, explotó las ventajas comparativas ambientales y humanas del país y sin duda agregó valor a las regiones del sur de Chile. O sea, tomó oportunidades de mercado, explotó ventajas comparativas con mucha transferencia y adaptación tecnológica y lo que es más importante en una innovación, agregó valor a la economía y al desarrollo social del sur del país. La innovación se ha convertido en un motor de la competitividad en el sentido de que las crisis y los desafíos impulsaron a lo largo del desarrollo de la industria a la innovación. Los proveedores de servicios locales del país desde el comienzo tuvieron la tarea, el desafío de reemplazar las importaciones de bienes, servicios, estábamos muy lejos, así es que esa fue la primera tarea. Innovar para adaptar, innovar para desarrollar también soluciones en el propio país y vencer también con agregación de valor la distancia hasta los mercados objetivos. Por lo tanto, la investigación, desarrollo e innovación y también la transferencia y adaptación tecnológica que fue muy activa en los inicios de la industria, forjaron, fueron forjando la resiliencia de este sector, como se ha expresado varias veces en el desarrollo y la evolución de la industria. ¿Cómo ha evolucionado en cifras la salmonicultura chilena? Ustedes ven ahí un cuadrito que es solo para el 2008-2018. Quise ponerlo porque refleja el crecimiento anterior y luego voy a mostrar otro del crecimiento actual. El crecimiento fue notable, espectacular, a tasas del 8-10% anual, desde los 2000, de los años 2000 en adelante, y tuvo esta caída que ustedes ven ahí en el 2009-2010 a raíz de la crisis del virus ISA. Pero aquí está el rol de la innovación, de un ecosistema fuerte en investigación y desarrollo que permitió salir muy rápidamente, de manera que la normalidad comenzó a recuperarse ya en el 2011. Las tasas en realidad comenzaron a cambiar a fines del 2010, gracias a una acción muy efectiva de la cooperación público-privada y académica. Si ustedes ven este otro cuadro que está aquí, podrán darse cuenta de la relación en el tiempo de las cosechas de salmón, que es la barra oscura, y de las exportaciones de salmón en toneladas, que es la barra más clara, y arriba el porcentaje que representan las exportaciones respecto a las cosechas en la línea gris. Y ustedes pueden ver que es bastante eficiente el uso del salmón en la materia prima y hemos estado en realidad con rendimientos agregados de las tres especies de salmón que se cultivan por sobre el 80%, lo cual es muy bueno. Y en total, con una producción que alcanza el 1.000.000 de toneladas, que este año va a estar un poco, o sea, el 2025, sobre el 1.000.000 de toneladas. Y con un valor de exportaciones de 6.500, como lo vemos acá, 750.000 toneladas de exportación y 6.500 millones de dólares en valor. Llegamos a 110 mercados extranjeros, 70.000 empleos directos e indirectos. Somos el segundo productor, como mencionamos, el segundo producto exportado desde Chile después del cobre. Hay 4.000 empresas de proveedores vinculadas a la industria de distintos tamaños, por supuesto, pero de esas, no menos de 300 desarrollan innovación en forma bastante sostenida según mi propia estimación. Eh, la salmonicultura representa el 90% de la acuicultura chilena y como señalé, también el salmón es en términos de cosecha el segundo productor mundial solo después de Noruega. El ecosistema de innovación creció asociado al clúster del salmón. La industria esta tuvo la característica de que partiendo de empresas productoras que hacían de todo, ellas tenían sus propios equipos de veterinarios, tenían sus propios sistemas de alimentación. Ese era el inicio. Y piensen ustedes que este inicio fue en zonas que en ese tiempo eran y siguen siendo remotas, están muy al sur de Chile, en fiordos, en canales, donde la conectividad era muy compleja y difícil. Entonces, eh, estas empresas de estas empresas fueron luego escindiéndose, saliendo, algunas empresas que se establecieron afuera, se tercerizaron servicios y eso lo tomaron profesionales que surgieron de las propias empresas y por lo tanto la relación que había entre proveedores y productores era muy grande en una región, en una zona y por lo tanto, aunque sea una zona extendida, todos nos conocíamos y eso genera confianza, contacto y mucha interacción, lo que facilita un clúster. Y en torno a ese clúster, bueno, surge un ecosistema que avanzó de un clúster natural hacia un ecosistema inteligente. Eso refleja solamente no empresas que están allí en blanco, o sea, con letras blancas, sino que los áreas o sectores en torno al núcleo productor, en las áreas en las que están los proveedores, más cercanos a los productores, los que están aquí, y más alejados los que han ido agregándose con posterioridad. Pero todos conforman un ecosistema muy importante con un desarrollo muy relevante de proveedores de base científico-tecnológica. Hay una fuerte innovación a lo largo de la cadena de valor, en genética, como ustedes ven ahí, en salud y bioseguridad, en nutrición, en gestión ambiental, en procesamiento y logística, ingeniería e infraestructura marítima y en tecnologías de información e inteligencia artificial, que han sido tecnologías transversales que se han ido incorporando en distintas soluciones a lo largo de la cadena de valor. Y esto tiene yo diría, un importante desarrollo reciente, que es en los últimos 7, 8 años el paso a la innovación colaborativa. Las empresas activamente innovaban, pero en forma individual. Y era importante generar una herramienta, en este caso una institución, una entidad que agrupara a las principales empresas dedicadas a la innovación, y se crea el Club Innovación Acuícola, que es en este caso quien ha acompañado esta iniciativa de la Embajada de Israel, y del cual soy director ejecutivo. Nuestro club es una comunidad de innovación colaborativa. Reúne a 36 organizaciones. Digo organizaciones porque también hay universidades, y donde esperamos incorporar más en el futuro próximo. Hay proveedores de bases científico-tecnológicas, ese es el foco, y también un grupo de colaboradores especializados en distintos aspectos enfocados a la innovación, que tienen que ver con comunicación estratégica, que tienen que ver con gestión de la innovación en la empresa, que dan soporte a los demás asociados y también proyectan su trabajo al exterior, enfocados en la innovación, en la colaboración y en el desarrollo de mercados. Esa es la tarea de nuestro club. Cuenta con varias plataformas de innovación, desde una plataforma en la comunicación de lo que es la acuicultura y especialmente la salmonicultura, que es el ABC, que tiene por finalidad, con la mayor objetividad posible, informar al público, a la gente en Chile y en el extranjero acerca del progreso de la industria, como una manera también de enfrentar la desinformación y fuertes campañas que muchas veces se sostienen desde algunos países extranjeros, y esto se hace con antecedentes científicos y técnicos, lo cual es muy importante. Hemos fundado una alianza internacional de innovación en acuicultura, la AIA. Hemos colaborado activamente con el Plan Innova Puerto Montt, que también es una plataforma muy importante en la capital regional, que se vincula, por cierto, muy activamente con la industria salmonera. Y tenemos una conferencia que queda siempre arriba en red, que ya tiene 3 versiones con muy importantes exposiciones y expositores, que puede ser visitada y donde hay mucha información. Una comunidad diversa y dinámica es la que conforma nuestro club. Hay empresas desde nacionales hasta multinacionales muy grandes. Lo interesante es que todos tienen el mismo nivel de consideración y de participación, son todos iguales, y solo nos une fuertemente el afán de colaborar. Se cubre toda la cadena de valor con los diferentes asociados, y estamos en una acción sostenida de exportar nuestras tecnologías y servicios también a otros mercados extranjeros. Y es ahí donde también vemos una oportunidad con proveedores de base científica tecnológica de Israel, donde sin duda alguna hay tecnologías que pueden potenciar las capacidades mutuas, más la experiencia que ha tenido Chile en el desarrollo de esta industria desde el origen. Eh, Hay diferentes áreas en el club, desde biología aplicada, ingeniería, informática, servicio de consultoría y capital humano, que están todos dispuestos a interactuar activamente con las empresas de Israel. Somos prestadores de servicio al foco de productores, y queremos ampliar nuestras capacidades, como ya lo estamos haciendo, a otras industrias, como señalé, la tilapia, en el camarón, donde la adaptación de nuestras tecnologías puede ser también de mucha contribución. Hay una serie de desarrollos de nuestras empresas del club, yo no quiero extenderme mucho, pero que van desde las vacunas, tratamientos terapéuticos, sistemas de gestión, instalaciones y protocolos modernos de bioensayos, etcétera, etcétera. Y también, desde el punto de vista de una perspectiva global, está el interés de avanzar con alianzas, con organismos internacionales y una apertura permanente, como señalé, de asociatividad internacional. Esto es muy interesante, las líneas lamentablemente no se ven de lo más claro, pero esto es lo que siempre perseguimos y esto es lo que hemos logrado en el club. Distintos niveles de interacción que reflejan las líneas que allí se observan entre nuestros asociados. Que esa es la idea. La idea es que puedan colaborar y puedan desarrollar soluciones conjuntas para desafíos cada vez más complejos de la industria acuícola en Chile y en el mundo. Ahí tenemos una serie de áreas de interés mutuo. El club cuenta con muchos servicios para sus asociados. Y en conclusión, simplemente decir que tenemos en Chile una industria en que la salmonicultura es muy fuerte, en que el ecosistema de innovación avanzó hacia un sistema colaborativo y es un forjador de la resiliencia de la industria del salmón. Así es que muy contento de estar participando hoy. Ese es nuestro contacto y muchas gracias, Valentina, y a la embajada por esta invitación.
Muchísimas gracias, Adolfo. Te pasaste por la presentación, por toda la información, por darnos una mirada eh, al mercado y a la industria chilena y por todo el también a todo el trabajo que han realizado en el Club de Innovación Acuícola. Así que muchísimas, muchísimas gracias.
Un gusto.
Definitivamente hay mucho
Excelente,
potencial.
Adolfo. Excelente,
Sí.
Adolfo.
Muchas gracias, Ariel.
Ahora seguimos con Roni Sussmann, Executive Director de Aquaculture Israel,
Hello,
AquaculTech.
everyone.
Roni, welcome.
Hello, hello.
Uh,
I'm sharing my
Hi.
slides.
Yes, please. Okay, no, we're seeing your Zoom. Okay,
Is
perfect.
that
Now we
fine?
can see your presentation. Yes, of course,
Hello,
the floor is all
everyone.
yours.
I would like to introduce you to AquaculTech, which is the Israeli biotechnology and aquaculture community of Israel.
Roni,
Uh,
sorry, can I interrupt?
yes, sure.
Solamente quiero recordarle a todos que contamos con traducción simultánea, que pueden encontrarlo en el mundito abajo donde están las herramientas del Zoom. Eso. Okay, Ronnie, just wanted to remind everybody about interpretation. Okay, please continue.
So hello, everybody. I would like to introduce you to AquaculTech, which is the Israeli biotechnology and aquaculture community. The community is a joint venture. It's a non-profit organization initiated by the Israeli Innovation Institute, the Ministry of Economy and Industry, the Ministry of Agriculture and Food Security, and Israel Innovation Authority. And we just had another ministry joining us, the Negev Galilee office. And it's a platform to boost biotechnology and aquaculture locally and globally, connect all the stakeholders from the academy through industry, entrepreneurs, investors, and all people that are interested and involved in aquaculture in Israel and around the world, to create an innovative ecosystem that will benefit from networking, knowledge sharing, and dealing with challenges. So the community in Israel is a bridge through all the ecosystem, from students to industry, researchers, NGO, corporate startups, entrepreneurs, service providers, and we create bridges between those sectors. I will skip to this slide. Through events, we initiate events. Normally, we initiate event when we get the idea for the event from the community, and we got through the past 4 years with tens of events that are students' events to promote early career programs, industry academy networks event, international conferences, professional workshops and seminars, startup pitch sessions to global stakeholders, B2B matching meetings, international delegations, and roundtable discussions and webinar just like this one. All of these events are to create connections between stakeholders in our community. I will run through the main missions. We map the Israeli ecosystem to create connections, map the global challenges, and promote our members globally to create economic growth that will lead to food security, both in Israel and around the world. And I want to present to you the Israeli industry map. It's divided to sectors: algae, fish, shellfish, corals, academy and research, technology providers to aquaculture, protein alternatives, innovation centers in Israel, and consultant. Israeli consultants are involved in projects around the world. And the Israeli Academy is over 25 academies and R&D centers. All have researchers through all these sectors that I just presented, and they are all are willing to cooperate and do both projects and both sharing IPs with any that are interested in aquaculture. And for example, if you press, this map is on our website. It's an interactive map. If you press any of these logos, you will reach a page. This is, for example, the Innovation Innovation Center page. And if you press the Innovation logo, you will reach this page. And you can press Introduce Me, and you will get an email straight to the person you can connect with in Innovation. And that's it. You're more than welcome to connect us, be part of the community, or reach out to any of the Israeli technology providers. Our next map that we are going to launch is going to be the Global Challenges map. And any challenge you will touch, you will see companies that are answering that challenge. And that's it. Thank you very much.
Thank you very much, Roni. Thank you very much for your presentation and for sharing what you do at AquaculTech in Israel. Thank you very, very much. Now we're going to go through the next portion of our webinar. We're going to the technical presentation of the companies. We're going to start with GoSmart Precision Fish Farming with Joseph Melchner. I don't know if I pronounced your...
No, that's perfectly correct.
Super. Welcome, Joseph. Muy bienvenido.
Muchas gracias.
Yes. Do you have your presentation?
I thought that you are put it online.
If you can share your presentation. Bueno, in the meantime, aprovecho de recordarles a todos que si están interesados, voy a dejar mi correo en el chat. Si están interesados en contactar alguna de estas empresas, me pueden escribir y nosotros vamos a hacer la conexión. ¿Sí? Porque Gonzalo estaba preguntando en el chat si es que se iban a compartir los correos, pero pueden escribirnos al correo que yo voy a dejar en el chat con el interés de la empresa que quieren, ¿sí? Gracias. Okay, Joseph.
Can you see the presentation?
Yes, we do. Can you please put it in presentation mode, please?
It is.
Oh. Okay, you took it out.
Okay, can you see it now, Valentina?
Yes, perfectly.
All right. So
Okay.
I will speak in English, and I hope that everything will be translated correctly.
Of course.
Thank you very much for inviting us to this conference and to see all the lovely people of the industry of Chile. In my background, I was a fish farmer, so I deal with the bits and bytes on the daily task. From that point, we decided to move to the aquaculture precision farming and to start to provide untapped data for the aquaculture industry. We decided to do that with the AI and computer vision, and I will let you understand how we are working on it and how we can benefit to the industry of Chile. So the problem is quite well known. We're losing something like a third of the production, causing by different problems, starting with inaccurate feeding plans that's causing to poor fish welfare. The entire industry is still high labor intensive, which need to transfer to automated or semi-automated industry in order to get more benefits and to get more profits for the sector in the entire sector globally. For the last 2 or 3 decades, the growth performance didn't change much, and not because of the skills of the farmers, because of the unknown data that was laying underwater. So if you're combining all those problems, the solution is to provide data, reliable data, real-time data, so the farmer can have the access to the data and to make decisions based on real-time information. GoSmart developed a system that is holistic solution suitable for all kinds of aquaculture techniques, starting from offshore cages all the way to the RAS facilities and the inland ponds. We're providing the information based on the data that we are collecting from underwater and above, putting them in a big data lake that we build and structure in the cloud. And from them, we are sending the outputs, the performance outputs for the farmer. The entire data collection and analysis, we are doing it in real time, which is extremely important to make operational decision based on the information and to make benefits out of them in the field. Our talent is the fish. We're focusing on the fish. He's the talent. He is the animal that we need to focus on. And we're taking the untapped data, starting with population of distribution, size, health control, and production yield improvement. And of course, we are doing it mainly with computer vision. We integrated into our system not just computer vision, but strong computing power that enable us to analyze the information in real time on site. So we're not transmitting the information to the cloud, making the analysis, and we have lagging behind the information that transmitting back to the farmer. We are analyzing the information on site and transmitting it to the farmer in any cell phone, tablet, PC, or any electronic devices that connected to the net. By doing that, we're optimizing the feeding. We are enhancing the fish welfare by providing them with accurate feed plan on the time that they want to eat. And how we do that? We use computer vision. We are analyzing the biomorphology of the fish with non-invasive product. We're talking about very compact and reliable equipment that is mounted on the cage, on the railing, on an existing infrastructure. And by doing that, we have no limitation time. We have no time limitation. So we are analyzing the cage every moment, almost 24 hours a day, 24/7. And on the right, you can see that we are not just analyzing the fish, the individual fish, but also the entire group. We are analyzing the behavior and providing a farmer essential output when the fish wants to eat, when they are hungry, what is their level of appetite. And by doing that, we are changing not just the welfare of the fish, but the entire logistics and providing the farmer with capabilities to automation. So imagine to yourself if we have the ability, and we do have right now the ability to monitor when the fish wants to eat. We have the ability to make the entire feeding process fully automated. So we know the size of the fish, we know the distribution of the population, and we know when the fish wants to eat. And this gives us the entire information for a full automated system. We integrated into our system some environmental sensors such as oxygen and temperature that complete the entire pictures and providing us with a whole new information. GoSmart started to work in 2020. We developed our product from scratch based on our experience, and we gathered a team of experts. We managed to develop a very reliable, compact, and affordable system, which we deployed in 9 countries already. And we already made first steps in Chile. So we have two units in Chile starting to work and operate. And hopefully next month we will increase our presence in Chile to provide more information to more customers. GoSmart is a high-tech company that we are supported by the big tech, thanks to the Israeli ecosystem that is in Israel, and some of the big tech companies such as Google and NVIDIA are supporting and participating with our R&D constantly and in a very efficient way that give us the ability to provide more information and more layers of data to the farmer with new algorithms and new data collection. We reach 95% accuracy plus, and that leads to 10 to 30% efficiencies in the feed optimization, in stock management, in the forecast of the fish readiness to harvest, and the quality of the fish. Our business model is simple. It's pay as you go. It's a SaaS or HaaS model, so it's no heavy capex on the farmer. The farmer is paying basically from the saving that he's getting from the system. So once the system is in the water, the farmer immediately start to get benefits and to cut in expenses and to log and to have data log of the entire operation. And we are collecting our compensation on a monthly or quarterly basis. So no heavy capex or a high-tech infrastructure that needs to be implemented and installed on the Chilean industry. So as I mentioned, in order to do that, we gather the top talents in Israel, and lucky us, we have a good ecosystem for high-tech innovation, high-tech industry. So we recruit top talents from different fields, starting with the AI and computer vision, all the way to the electronics, communication, mechanical tasks. And of course, without the leading management team, we were not able to do that. So thank you very much. You're most welcome to contact us whenever you want and explore our website. And it will be our pleasure to be more present and to make a bigger footprint in the Chilean industry. Thank you.
Hi, Joseph. Thank you very, very much for your presentation. Remember, everybody, that you can leave. Le recuerdo a todos que pueden dejar preguntas en el chat, que las vamos a responder al final. Ahora seguimos con Yaron Bardal de Mariculture Systems.
Global, they put some a little bit like in what happening around the world, but small bit at the end.
Hi, Yaron. Yaron.
Yes, hello.
Hi.
You
Super.
see my screen?
Yes.
Very good.
I'm
I
sure
hope
they
also
have
that.
one person with this email
Puedo
every
ver
day.
en el público que Jorge quiere hablar. Jorge, te pido por favor si puedes escribir en el chat. No puedo, no tengo la habilidad para... para dar la palabra por acá, pero puedes escribir en el chat, por favor. También dejé mi correo en el chat para que puedas escribir cualquier cosa. So, Yaron, please, the floor is all yours.
Okay. So my name is Yaron Bartal. I'm the CEO of Mariculture Systems. What we do is we developed a platform that can grow fish in the open sea, a very large volume of fish in a sustainable way. So we call it open sea, large volume, sustainable aquaculture. So the need for fish, the demand is growing. Everybody knows that very much. And the existing technologies probably or in many areas have troubles or struggling to meet this growing demand, either by lack of coastal space, by environmental regulation, and tourism priorities, which cause public pushback. Also, RAS is not succeeding in large volumes as expected, and the big companies are investing a lot of money and losing a lot of money, as you can see here by two American companies that are, it was published, the losses are in hundreds of millions. So the solution to those issues is going offshore. Not offshore in small, but offshore in large. And again, large volume and sustainable in a sustainable way. Now, why offshore? First of all, the water characteristics are best to grow fish there. And the number one priority for that is the levels of dissolved oxygen in the water. I'm sure most of you are familiar with the graph on the right, that as the higher the dissolved oxygen in the water, the faster the fish grow, the lower the mortality, and the lower food conversion ratio. Everything that a farmer is looking for. Besides that, there are currents in the open sea, which are good for the fish. Fish like to swim against currents. And the temperature is relatively stable, much more stable than in shallow waters near the shores. And all of that brings to that both practical experience and the research articles are showing that fish that raised in the offshore usually have better taste, smell, texture, and overall are healthier compared to those from near shore or in RAS. No aftertaste and things like that that you're probably all familiar with. Now, we are not the first one talking about offshore. You can see this trend growing in Norway mainly and in China. There are various types of big platforms. However, all of these are designed, they call it exposed weather, meaning they can withstand the medium sea conditions, but not the very harsh one. Take, for example, the Hav Farm. That's the green ship without bottom in the middle of the right, here. This is, by the way, this is about 400 meters long, so this is very big. And in summer, they anchor it outside the fjord, and in winters they push back and hide in the getting the protection of the fjords. So those are very large, floating and submerged. And you can see here, for example, the Chinese one when it's floating and when it's submerged. We believe that our solution, based on a semi-submersible platform, is overcoming all the problems and the issues and the limitations that the other platforms have, and they cost less. It's not a cheap system, but they cost less per cubic meter of water to grow fish. Now, how it works. This on the right is a semi-submersible rig. Submersible, imagine a big floating table. And when I say big, it's really big. It's 50, the plate here, the plate of the table, so-called, is 50 by 50 meters. And each one of those legs is 30 meters long. And because the legs are hollow, it floats. Around the system, there are fish cages that can be designed in any shape. They are here around for our specific first project in Portugal, but they can be adapted to any shape according to the farmer's requirement, to the species, and so on. The cages are connected together in a steel frame, and they are hanged to the rig. When the waves start to become high, we lower the cages. As I said, they are hanged, so we lower the cages, and in this way, we actually allow the fish to behave in their natural behavior, which is diving during storms. They don't like the upper layers of the ocean, turbulence, harsh currents, so they dive. And what we do is just allow them to dive. Talking a little bit about the highlights of the platform, the volume of the cages in this round configuration is 350,000 cubic meters, and it can be enlarged to 500,000 cubic meters. And that translates to, give or take, 10,000 tons of fish per year. It was tested for 17 meters high waves. It is sustainable, meaning that most of its energy comes from renewable sources. There are solar panels covering the entire platform. It's not seen in the picture, but it's like that. There is continuous operation, 365 days a year, 24/7. There is a crew of 5-6 people doing all the handling with the fish. There is built-in cameras and AI-based fish grow control and monitoring, similar or even exact to what Yossi described in the previous presentation. Those cameras we do, or with the AI, we do three things. We do continuous biomass estimation, which is extremely important to know how the fish grow. We do fish feed optimization, and we monitor the fish well-being. So in some cases, the fish are will not feel good before the fish know that, by themselves. And there can be added also lice counting and things like that for the fish well-being. The feeding is done also when the fish are in lower position, when the cages are in lower position, thus being much more efficient, because every day you don't feed the fish is a day that the fish doesn't grow, and eventually you lose money on that. Our first projects are in Portugal and in Israel, growing sea bream and sea bass. However, in this platform, we can, with minor changes, grow any kind of species that is known to the aquaculture, including Atlantic salmon, of course. In that case, we already have a design to add air domes, so when the fish are in lower positions, they can do their balancing and all they need. We are talking with Norwegian companies that they want to flip the way of operation, meaning that most of the time the cages will be in lower position, so the fish will be in deep seas between 60 and 30 meters below sea level. So the sea lice issue will be minimized or even eliminated. What we are looking for is local partners globally to implement the technology. The business model is either a joint venture or we can be equipment provider. It depends on the partnership. And I would say that's it. And thank you for listening. And I will be happy to answer later on to the Q&A if there are any.
Thank you, Yaron. Thank you very much for your presentation. There are some questions at the moment, so we will answer them by the end.
Sure.
Les recuerdo a todos que hay una casilla especial para preguntas, no el chat, porque ese está bloqueado. Así que pueden hacer sus preguntas por ahí. Ahora los dejo con Uriel Buleg de BioLED. Esta presentación va a ser en español. Uriel,
Un
¿estás por
minuto.
ahí?
Sí, estoy
claro.
aquí. Sí, sí, estoy aquí. Segundito. Share. Aquí está. Y con... ¿Estamos todos? ¿Todos me ven?
Sí. No vemos
Ok,
Tienes la cámara apagada, pero vemos tu presentación perfecto.
lo importante en este momento es la presentación.
Pero,
Un placer encontrarme con ustedes. Esta presentación no va a ser solamente en español porque los términos tecnológicos no los conozco en español. Como ya dije, soy de origen argentino. También me disculpé que nadie es perfecto, lo dije desde un principio. Y parte de la presentación será en inglés. Bueno, soy el director general y fundador de la empresa BioLED. BioLED es una empresa electrónica y software y lo que hacemos es luz para la agricultura. Eh, Smart lighting, we call it smart lighting. We do advancing engineering and we optimize our solutions according to the farmer needs. We cover, so sorry, I moved to English. We cover most of the agriculture markets according to the demand. As you can see, we did huge cannabis projects in Israel. This industry now is almost dead. We did, and we're still doing big projects in China. We are working now with salmon, and we're working with hen houses. We have a global distributor, which is Plason, a very large company of Israel. They do also aquaculture. I believe that my colleagues know them very well. And let's talk about salmon, because for me is new, I have to tell you. I was contacted from a company called Spring Salmon, which is in Kibbutz Del Eliyahu. They also are our customers because they produce bees for not for honey, for plant reproduction. And we know and we learn that the light has an impact, a big impact in the growth of salmon. We did a test in a research institute, which is called Eden Farm in the Spring Valley. And they are researching salmon growing, and the impact was incredible, extremely change in the results of the growing salmon. We know that when we provide light to salmons, we affect many things, the growth performance, the FCR, the feed efficiency. They eat less and they grow faster. The fish welfare. I will leave this presentation to you so you can read also the small letters. I don't like to talk to explain the small letters, but we know how to control the spectrum and the intensity of the light. We do it always. Spectrum, intensity, and scheduling of the light. And if we do and provide the specific parameters, we can reach excellent results. So our company knows how to tune the spectrum, how to control the intensity, and most of everything is that I was told to tell you, that we produce extremely efficient light and lightweight that can be installed in indoor and outdoor environments. I will show you how it looks like. We can create a protocol. We could work with this AI company that presented before. That will be my pleasure to do that. And we have also extreme environment durability, and very, very easy to install and control. This is just an example of the system that we are installing now these days. We provide the light over the pool, over the growing pool, and we can control each sector of the growing facility with the specific protocol that is we need to control. We know how to connect to an existing management system, or we can provide our own management systems that will include sensors that can be controlled through any platform as you want. And we are also capable of provide a SaaS business model or a vendor business model. I will try to go faster. Okay. Also, we know how to manage the light in terms of spectrum, intensity, and scheduling. This is easily way to control. We can program a protocol for daily lighting, weekly lighting, monthly, summer, winter, spring, or autumn, indoor or outdoor, and we can control to sensors and the camera, as we talked before. And I will just, as I told you, we are provider of lighting technology for many type of projects, and we perform what is requested by the agronomist in special way. This is a huge project we did in Arava for azot algae. Sorry, this is vertical farming we did all over the world, and this is in Iktora, in the kibbutz Iktora, Alga project. Also vertical farming, hen houses, or as we do hen houses, special lighting for hen houses. As I told you before, our worldwide distributor is Plason. They have branches all over the world. Another installation in Brazil. And this is, we are testing the parameters. And we do also cow farms in the north with another research institute that calls Magal. They are in Kiryat Shmona. This is the way they look, the light. It can, as I told you, they can be indoor or outdoor, very easy to install. And this is the cows, cannabis projects all over the world. This is in China, peppers farms, photosynthetic lighting solutions. And also we are working with the Volcanic Institute in photofumigation. So my message to you is that regarding salmon, according to the needs and the new research that are coming to the world, we are capable to provide you the best solution you can find and a very good efficiency and pricing. And still showing you, this is another installation in China, flowers, roses in Israel, sprouts for feeding cows. And this is what we know, this is what we do. We take the new technologies of the LED and provide smart lighting systems for the agriculture. Thank you very much.
Muchísimas gracias, Uriel, por tu presentación. Nuevamente les recuerdo a todos que pueden dejar preguntas en la casilla de preguntas. Pero muchas, muchas gracias. Ahora los
Un placer, un placer. Muchas gracias.
No, a ti. Y ahora los dejo con Uri Weishaus de BlueGreen. Uri, welcome.
Hola, can you hear me?
Yes.
Let me
Very
share
well.
my screen.
Okay. It's loading. Wait.
Am I in presentation mode?
Perfect. No, we can see the whole program. Okay, now it's in presentation mode.
Great. So BlueGreen is a water company, a water treatment company. We've been around since 2014, and we make water safe. We treat mainly toxic algal blooms and related biological phenomena, mostly in freshwater, but also recently we've moved to saltwater as well. So if you have to remember two things about what we do, we have services for remediation of water, any kind of use, drinking water or others. And we improve the general sanitation conditions of water for aquaculture. So it could be anywhere from parasites, sea lice, shrimp industry. The main focus of what we do is toxic algal blooms, cyanobacteria. They're everywhere. They have nutrients, and in the salmon industry, we're talking about nutrients generated from the actual grow. So when you have nutrients, these organisms and similar organisms, cyanobacteria or others, either in fjords, in saltwater, in freshwater, they thrive, they multiply, and they create these kind of algal blooms, which are extremely toxic. Even if they don't kill the salmon, they actually cause damages in flavor and quality, and they reduce the FCR. They cause the salmon to stop feeding or eat less and grow slower. So most of what we do is around toxic algal blooms in freshwater. We have 10 years of experience in remediating lakes from the toxic algal blooms. And it's a problem that causes damages, financial, health hazard, environmental, every water use, and especially in the salmon industry. I don't need to elaborate. In recent years, there were severe damages to complete losses of crop. Just in 2021, 2024, floating cages or cages in fjords or in other places are affected by toxic algal blooms. It's not one species, it's multiple species. They come out of nowhere, and there's not a real way to control these. So I'm going to touch on what we have been doing in this avenue. And our solution is fairly simple. We have several active ingredients. I'll talk about one, but the principle is the same. Our products are called LakeGuard. Technology is called LakeGuard. So we've taken the active ingredient that's certified and approved for water use, and it's of 60 US EPA approved. So there's environmental approvals. So we've taken the active ingredient and we've coating it with a food grade biodegradable coating that's very thin. And the entire particle is 0.5 to 1.5 millimeter. Now we have floating and slow release mechanism of the active ingredient. In this case, the active ingredient is peroxide. So we have slow release floating peroxide from top down. Hydrogen peroxide on its own breaks up into water and oxygen, so it's completely zero footprint, and it improves the sanitation of everything underneath. If it's toxic algal blooms, then we get rid of the toxic algal blooms. If it's other parasites, then the parasites are impacted by the peroxide. Here's what it looks like in freshwater. I hope the movie starts. The delivery is super easy, either by boat or by crop duster or manually. In the case of floating cages, we would have to use a boat. But the idea is that we deliver the compound, it floats around and moves and follows the algal blooms where they're concentrating. So you could drop downwind and move around with the wind and current. We've used barges, we've used helicopters, we've used manual deployment depending on ease of application and budget. The mechanism is really straightforward. We induce oxidative stress by peroxide. We trigger something called PCD, a natural mechanism in the organism, and we trigger the collapse of the entire algal bloom. And sooner or later, other organisms thrive. Usually these would be green algae, and you have remediation of the ecosystem. We get rid of the toxic algal blooms, and they broadcast the signal to the entire population. And we also optimize our treatment. We have our own remote sensing capabilities. We use satellite-based and drone-based capabilities to impact or to optimize the treatment, so we can treat vast areas in lakes and even in the oceans where it's best needed. We track the algal bloom in real time or near real time, and we treat it, and we predict where the algal will concentrate and treat there. I won't go into the technical details. We have on-ground and above-ground monitoring systems to optimize the system and to maintain, and actually can provide warning systems for the aquatic systems. And the overall advantages of this is that we can treat entire lakes or entire ecosystems from outside with a floating algicide, and it becomes cost-effective. It's fully regulated where we operate, and it really is the only solution to get rid of the entire algal bloom situation. Now, recently, and this is really news from last week, we have been collaborating with the Mote Institute in the US, in Florida, with excellent results on red tides, which is a similar phenomena to the algal blooms in Chile. This organism is called Carenia brevis. We've shown that it's safe to use, and that we can actually deploy and kill the Carenia brevis and get rid of the algal bloom. We're now moving to tier 4 studies, which is in the real vicinity of the treatment. So we actually can demonstrate that we are cost effective and we can get rid of the toxic algal blooms in the ocean in Florida. Another possible use that we've been exploring, and this is open for communication, we don't have results yet, we don't have data to show, but it is well established that peroxide is a very good disinfectant and to repel and get rid of sea lice. So by deploying on-site a steady release of peroxide, you can actually have a low-cost, effective, low dose of peroxide. And we haven't tried this with salmon, but we think that if we use this at the right dose, we will have a steady concentration of peroxide, and it makes it feasible to use this and prevent the sea lice from actually adhering and sticking to the salmon. So if you would like to do a study like this, to do this with us, we'd be happy to collaborate on this, and feel free to reach out with our email and contacts and ask questions, and we'll be happy to answer if we can help the salmon industry.
Thank you, Odi. Thank you very, very much for your presentation. There are also some questions for you that we will answer at the end. Now we continue with Ofer Merashe from BioCastle.
Yes, just want
Menashe. Sorry,
to
I wrote it
upload.
wrong in my notebook.
No
Often,
problem.
please, the
Just
floor
a
is
moment.
all
Let me
yours.
upload.
Of course.
Thanks. Can you hear me, everyone?
Yes, we can hear you,
Good. I
but
just want
you're
to
sharing
adjust.
your whole screen so we can see everything.
Yeah, I know. I will try. Yeah, I will try to see. Where's the lecture? Okay. Now you can see the lecture
No,
in
we're
more
still seeing
presentation.
all your screen.
Oh, just a moment. So, and now
Okay, now we see your presentation.
can you see it?
Perfect. Yes.
Okay. First of all, great. First of all, thank you very much for the invitation and the opportunity to present our technology. My name is Professor Ophir Menashe. I'm the CTO of BioCastle and the CTO of Fishways. This is the technology that I will present today is for Fishways. And also I'm the head of a master degree, international master degree in water engineering at Kinneret Academic College. Just a moment. Okay. So what we are talking today is about RAS system, recirculated aquaculture system, but in a way we change this system. We will talk about how we changing the biofilter, which is the heart of the system, the most infrastructure, large infrastructure inside this system. We're talking about inland system, growing fish, and today we will focus about the biofilter. So the technology itself, it's coming from wastewater treatment. We were using bioaugmentation, which means that we are using a special bacteria culture to induce a special biochemical process. For instance, in aquaculture, we are having a great interest in nitrification. That means we are trying to converting or oxidizing ammonia into nitrate and nitrate. Ammonia and nitrate is very toxic for the fish. This is why we need a huge bioreactors, which means that we are growing a sludge or biofilling with the bacteria inside the fish farm, and only small part of this biomass, huge biomass inside this biofilter, is a nitrifier. That means a bacteria know how to oxidize the nitrogen, which is the most toxic element to the fish. Now, our question was, what if we can convert this 5% of nitrifiers into 95%? That means if we have a biofilter which have a volume of 1,000 cubic meter, we can reduce it into 10 cubic meter. That's huge. That changed the game. It's not only about a biofilter, because then we understood that this huge biofilter is also consuming oxygen. It is also secreting geosmin, which is a byproduct, bacterial byproduct of some heterotrophic bacteria that damaging the smell and the taste of the fish, and also provide pathogens and parasites. So it's not only infrastructure, actually, it's changing everything. It's changing the entire picture. So the capsule itself, it's about 2.5. It's a bioreactor, actually. It's a very small bioreactor. This is why we call it SBP, small bioreactor platform. It's coating with a microfiltration membrane. The bacteria is inside. It cannot escape from the membrane or from the capsule. And the nitrogen compounds are trafficking across the membrane according to the law of diffusion. As you can see it, microfiltration membrane about 0.8 micrometers, pores. The bacteria is a little bit larger than 0.8 micrometers, so they cannot escape. Other microorganisms cannot get in. only the dissolved element can transfer across the membrane. The implementation inside the cages, the fish cages, is with a perforated cages attached to the side of the pond. Actually, as you can see, we are bringing the biofilter inside the growing fish pond. What we can achieve from that, first of all, we are saving a lot of energy by canceling the major hydraulic cycle of the RAS. Water is very heavy. The hydraulic retention time of the fish pond is about 1 hour. We all the time circulate the water between the biofilter and the fish pond, and now we can save it. We can save this hydraulic cycle. We can save a lot of energy by canceling the biofilter and transfer the filter itself, the capsule, inside the fish ponds. We tried several, we have several case studies. One is with sea bream. We managed to reach about 25 kilogram per cubic meter in 10 months, about 500 grams of fish. The purging was only 3 days with no geosmin smell or of taste. This is huge. Sorry. So 25 kilogram per cubic meter, 60 grams to 450 grams. We continue this study into 550 grams each fish. And a daily water exchange was about 0.5%. Yes, we did also denitrification process and return the water into the fish. Because this was a marine water, we cannot dispose it into the sewage. The facility, the test facility, was 90 kilometers from the sea, inland. Now, the next case study was with salmon. We used the cold water nitrifiers. We brought the eggs, the fish eggs from Iceland. It's Atlantic salmon. And now the salmon is about 800 grams. The biofilter is inside the fish ponds. And they're growing very good. Today, we already achieved more than 35 kilogram per cubic meter. It's about 50 kilogram per cubic meter, and the fish is still growing on, sorry. You can see it all the stages from eggs to fingerling and continue growing. So, in summary, we have some experience with sea bream and salmon, Atlantic salmon. In several cases, we have no external biofilter required, which means we're looking for a lower energy consumption and reduce infrastructure, of course. We eliminate the external biofilter and ensuring enhanced biosafety by reduce the amount of bacteria and parasites inside the system. Also, improving the taste, not having geosmin taste inside the fish flesh, which is one of the most problems in the RAS system, and the purging time is much more reduced. It's about 3 to 5 days only, just to treat the stomach, to empty the stomach, and not losing by the purging more fish flesh during this time. Thank you very much. I'm open for questions after the end of the session.
Thank you, Ophir. Thank you very, very much. I see that some of you guys are answering the questions already in the chat, so thank you very much for that. And now, last but not least, we will go with Oz Bornstein
Yes, hello.
from BVACT. So Oz, the floor is all yours.
Thank you very much. My name is Oz Bornstein, and I'm one of the co-founder and the CEO of VBACT. VBACT is solving a very basic problem of bacterial detection. Today, still, bacterial detection is a slow, manual, sometimes even costly process. It takes days to get a single result. You need to send somebody to the water source, take the sample, transfer it to the lab, wait 1, 2, 3 days, and you get a single result after a few days. VBACT has developed an imaging technology together with AI image processing algorithms, very powerful algorithms. So we replace, with the power of optics and computerized algorithms, biochemistry processes. And we open the door to totally new capabilities. We can detect and monitor water for microbial contamination in real time, continuously, 24/7, fully automatically, and without any reagent, which simplify the process a lot and basically offering the lowest operational cost solution in the market. Today, this system is already in the market and offer 4 different critical water quality parameters simultaneously, and we can add more parameters over time on the same existing system. The parameters are bacterial total count. We detect all bacteria. Microparticles, which is another important measurement to the quality of the water. So we also detect microparticles total count, size distribution of the bacteria and the particles, and we have, from last year, a totally new tool. This is the first ever bacterial population composition classifier. It's called...
Sorry, Oz, but I don't know if you were planning to show a presentation, because we only...
Yes. This is just the...
Okay, we're still at the beginning, the first slide, that's all.
Yes, this is the first slide, and I'm just changing it right now. Okay, so this is the PhenoMonitor. A few words about ourselves. We are 2 co-founders. We have private investors, and we have an industrial partner. It's an Israeli-German group that is responsible for the engineering and production of our systems. And our mission is really to provide microbial industrial automations to various sectors. We mainly serve the food and beverage producers, public water suppliers, and also health and wellness producers. We have already installation in the EU, in Israel, in Africa, in Latam, and in the United States. Few words about the technology, and I'm starting from the left. The flow of the water and the technology is starting from the left. So water is flowing into our system 24/7 all the time. They are passing a transparent flow cell. At this point, they are being imaged very quickly, very rapidly. The images, which are non-trivial images, that are unique images that allow us to differentiate between bacteria and general debris and other microorganisms in the water, are analyzed immediately in real time with our AI engine, image processing engine, and the results are presented in a dynamic updating graph. This is the main dashboard, and we have 2 dashboards. One is a web-based dashboard, and this is the system dashboard. The system dashboard in this example show you the strengths of a real-time continuous monitoring. Here we have an example of monitoring a water source starting from the left. and you see that at the beginning, the water quality is stable and good, that it's a low-level bacterial count. Once contamination started to emerge, the system immediately, not after 1, 2, 3 days, immediately in real time, the system pick up the contamination, and the counts are increasing gradually until it reach the amount of the bacteria, the contaminated bacteria amount in the water. It stays there as long as the contamination exists. And once the contamination is flowing away, the system starts to report that the level of bacteria is reducing. So with this technology and with this solution, you can know exactly at which time the contamination starts, at which time it ends, and what was the severeness or the magnitude of the bacterial contamination, and you can decide which action you need to take upon this information. So you can react in real time with all the information in your hands. Next year, we are planning to add a fifth detector. It will be a biofilm detector. Biofilm is a clump. It's an aggregate of bacteria clumped together, usually within water infrastructure. Inside, it's very hard to detect them. And all these detectors can monitor the water simultaneously. The smallest graph is a microparticles monitoring detector. Again, usually from our experience, vast experience, when you have a bacterial contamination, you will see a parallel increase in the microparticles count. And by the way, this is a real count. You get a number. This is not a turbidity method that gives you an NTU number, whatever it stands for. This is a real count. You have X amount of particles, and you can get their size distribution. If you use some kind of water treatment, you can validate or optimize the water treatment processes by understanding what was the count before the treatment and what is the count after the treatment. We have also a web-based dashboard, and it will run once while I will speak, that allows everybody that is connected to the system. If the system is connected to a network and another computers are connected as well, everybody can log in and see the results in real time and also look at the historical result and make a lot of analysis. This you can do with your personal PC, with a standard web browser. So this is very helpful and easy. This slide speaks about the PhenoMonitor. This is the first ever bacterial composition classifier, and it has a few purposes. The first is to monitor the water quality stability in terms of the bacterial population. Once there is a bacterial contamination, the bacterial population is changing. There is a shift, and we detect that in real time. More than that, if there is a biological or chemical contamination, and such contamination will alter the bacterial population, it will detect that as well and can report that to you in real time. Another internal tool that this PhenoMonitor classifier has, it's called Event Tracker. Let's assume you add a validated bacterial contamination event. With one click, you can record this event in the system. Let's assume you add yesterday a major coliform contamination in your water source. So if the system was on that water source, you can, with one click, create a profile of this contamination. And from that point of time, this tool will start to look for a match with similar characteristic. This tool has 150 different parameters. So if you set up a high probability bar, it will report you once it will detect a recurring contamination event with the same properties. The system is also autonomous. It can be placed in remote unmanned site. If there is electrical failure, it can recover automatically and calibrate itself and start over the monitoring process. It creates a big data. It provides you thousands of readings per day and compare it to a single reading with a Petri dish. And it has the lowest operational cost in the market, basically $8 per day for thousands of reading of 4 simultaneous different parameters. A few technical issues. We have a periodical disposable element. This is the item in the middle. It's called the cartridge. This is basically the flow cell with some kind of pre-filtration at the top right. Just to prevent the blockage of the system with very large debris or particles. It has 30 micron filtration, nominal mesh filtration, and the water flowing all the time inside. So once a month, it needs to be replaced, but this is basically almost the only item. There is also an automatic washing unit that is attached to the system, needs to be refilled with a standard detergent once every 2 months, and that's it. No other hassle or maintenance task that you need to take care of the system. The system consumes 6 liters per hour. It has the largest dynamic range in the industry, from basically a zero or a single bacteria up to 5 million bacteria without any further intermediate steps. And I will continue to various use cases. In many places, you can see different installation, but the main issue is early warning of bacterial contamination and detecting vulnerabilities in your water source or in your water, I would say, infrastructure or water system. It's also an excellent tool to validate and optimize water treatment processes, and it can save you, it has a lot of saving elements by reducing the conventional testing and other elements. I will conclude here because I think that the time is over, and I'll be happy to take your questions later if you have some. Thank you very much.
Thank you very much, Oz, for your presentation as well. Now, if you can stop sharing,
yes,
please, so I can see everybody.
Yes.
Thank you very much, everybody, for your presentations. I have a few questions. These are actually for VBACT and for GoSmart Precision Fishing. So the question is, how does a typical commercial deployment timeline look like, basically? How long does it take for your, after you make the business, etc., to deploy your technology and actually see results? So maybe, well, Oz, because I cannot.
Okay.
Yeah.
The installation is pretty simple. We just need a standard electricity outlet, flat surface, water source. We took the 6 liters per hour to the drain usually, but you can recycle it because we are not touching the water. So the installation can be done within an hour, I would say, if everything is there already. Obviously, there is some training for somebody to be responsible over the system, but the system provides you alert if there is something faulty with the system. So the installation and the maintenance are simple and quite low, and it can be applicable in many places.
Okay, thank you. Joseph, are you there? Joseph Mechner? Okay, well, maybe we lost him for a little bit. That's okay. For Mariculture Systems, what are the main barriers to adoption you encounter when entering new markets?
There are two barriers. One is regulatory, that not all countries have the regulatory path for offshore aquaculture. For example, Norway is now starting that. They defined areas. Scotland is doing a trial for 12 nautical miles, similar to what they have now in 3. So this is the first barrier, to have a license, concession, whatever it's called. And the second is financing. It's a big and costly project. So the financials are excellent, return on investment, ROI, but all of that are good, but it takes a big investment to do that because it's big, 10,000 tons of fish.
I understand. Joseph, good to have you
Yes.
back.
Thank
So
you.
the question was about a timeline. How long does it take for your solution from when you do the business to deployment and then to see the results? How long does it take?
It's quite fast. It's immediate because we already have the product. It's ready. The moment we're getting the purchase order, around 1.5 months later, we can start the installation. The moment the system is installed and mounted on the cage, the very first second we can start to see the results. So we're collecting the data, and after the very first 5 days, we can start submitting the results of the average weight, distribution, grow out performances. And on the very first day, we can see the fish behavior from the feeding camera, and it's an immediate output that transmit directly to the farmer. So it's a very quite fast data analysis.
Okay. Sorry. VBACT, what kind of partners are you looking for to accelerate the adoption in new markets?
At the end of the day, we need a local partner first for the sales and the marketing that is know the language, the culture, the way to do business locally, and to give service, because there could be a chance that there is a physical damage. Somebody, I don't know, made an accident and hit the system, and somebody needs to be there, a technician needs to be there to maybe to replace a card. Most of I would say, the issues can be done from remote. We have remote access to the system, and we solve most of the issues from remote. But again, I would say mainly for sales and marketing, and give some confidence, local confidence to the end customers locally.
Thank you. Also for Violet, what type of commercial partnerships are you looking for in Chile?
Hola. I'm looking for distributors, partner. We can share, we can produce there, wherever, open for every kind of business.
Okay.
Produce there, install there, also maybe try with other type of agriculture needs, wherever is needed.
Thank you very much. And I think that these are the questions that we have so far. I know that you already answered many of the questions on the Q&A box. Así que vamos a cerrar. Muchas gracias a todos los que estuvieron hoy día. Por favor, recuerden que si desean contactar a estas empresas u otras del sector en Israel, está mi contacto en el chat, así que pueden escribirme. Y los que se registraron para tener reuniones, los vamos a contactar después de esto para coordinar. Thank you very much, everybody, for all your presentations. Also, thank you very much to the Israel Export Institute for all your hard work coordinating and scouting the companies, and al Club de Innovación ACUICOLA también. Muchísimas gracias por su presentación, por el trabajo en conjunto, por el conocimiento. Así que feliz de seguir trabajando juntos para encontrar oportunidades win-win para ambos mercados. Muchas gracias a todos y que tengan un excelente día. Hasta luego.
Thank
Muy
you.
bien, Valentina. Genial.
Gracias, Valentina, por todo.
Hasta luego,
Hasta
chao.
luego.